Okay, this is part 2 of this June 2023 IGCSE Edexcel physics exam. It's the one paper that the double science also have to do. We went through questions 1 to 3 in part 1. Here's part 2. It says question 4, ground penetrating radar, GPR for short, uses radio waves to detect changes in material underground. State the formula linking speed, frequency, and wavelength of a wave. Remember, you're given the equation sheet, so it's a very easy mark. You're meant to really, in physics, strictly speaking, use word equations, but if you've used the correct symbols, they will give you the marks, so the accepted symbols. You can see the way I've drawn arrows from the words to the symbols to just make sure the examiner knows that I know what each symbol stands for. Okay, and that's why they normally prefer you to use word equations, and that's the normal way in physics. A definition is often given as a word equation. GPR, radio waves, have a frequency of 170 megahertz. Well, megahertz means times 10 to the 6 hertz. If you don't know your prefixes, these are called prefixes, like kilo, mega, giga, go and learn them before your exam. So both going up, they go up in powers of 3, so 10 to the 3 is kilo, 10 to the 6 is mega, 10 to the 9 is giga, and then if you go from below 1, fraction, 10 to the minus 3 is milli, 10 to the minus 6 is micro, and 10 to the minus 9 is nanotechnology. You've all heard of it. The speed of radio waves is given as 3.0 times 10 to the 8 meters per second. And you can see now you've got 10 to the 6 in the frequency, a 10 to the 8 in speed or velocity. Okay, so now all you've got to do is calculate the wavelength. Well, wavelength is the term lambda. So lambda, changing the equation around, shows you know what you're doing. And you can see how 10 to the 8 and 10 to the 6 can simplify to just 100. Yeah, because the top has 10 to the 2 more than than the bottom. So it's basically 300 divided by 170. Which gives you to 4 significant 1.765 meters, the wavelength. But you should round it up to 2 significant figures because the data provided is only accurate to 2 significant figures. That's how you know how many significant figures you should quote. The same goes for A-level. So when I do these GCSE papers, I'm showing you how to do physics correctly, which best prepares you for A-level. Okay, then it's part B. It says a radio wave passes through the ground and refracts at the boundary between soil and rock. So you can see the boundary is here between soil and rock. The diagram shows 3 wavefronts. Which 3? It's showing you 3 wavefronts. So wavefronts are like looking at the waves. The helicopter view, if you like, if you're looking at water waves, will be the waves seen from above if you're traveling in a helicopter. So they're kind of, you could assume that they are the peaks of the waves, okay? So you can see the 3 wavefronts of the wave before and after refraction. So they've shown them before, the ones I just circled, and after in the rock, you can see the wavefronts get bunched up. Okay, which is, that will be the next part of the question. The wave is also reflected partially at the boundary. Okay, there will always be some reflection at a boundary, and it's obviously between soil and rock. So they want you to complete the diagram to show 3 wavefronts as I've drawn after the wave has been reflected. So reflected means bouncing back. And you know that the angle of incidence for reflection should be equal, roughly speaking, in your diagram. By the eye, it should be drawn at roughly the same angle. However, they're not being very fussy in this mark scheme. They want you to draw the ray, so reflecting in roughly the correct direction, 1 mark. 3 wavefronts, because they told you to draw 3. Now they should be equally spaced if they're reflecting, because they're still going through the same medium. They'll still be in the soil. And of course they must be parallel, so if you've drawn them in a messy way, you could lose 1 mark. All right, so use a pencil and a ruler in the exam. Part 3, it says explain why the radio waves passing through the rock have a smaller wavelength, than the radio waves passing through the soil. Well, we just saw that in a diagram, The wavefronts in the rock are much closer. That means the wavelength has got shorter. So the wavefronts, the distance between them is the wavelength. So explain why, the wavelength is smaller in the rock. So smaller wavelength, you can tell, means that the wavefronts are closer together. So if you say that the wavefronts are closer together, you'll get 1 mark. And then explain why. So you can't just say it, you've got to explain why. This is because the rock is denser, optically, in this case, with whatever wavelengths they're using. It's denser for this wavelength of radiation that's going through than soil. So it's more difficult for the waves to travel through, but you've basically got to talk about the density, to do for waves. The radio waves then, so that's 2 marks just for saying that. The radio waves travel through rock at a reduced speed, Remember, refraction happens at the boundary from one medium to the other due to the difference in density. And in the denser medium, there will be a reduced speed, And since v equals f lambda, if the speed goes down, the frequency, remember, remains constant. If the speed goes down and the frequency remains constant, that's why the wavelength will also go down. So any of the underlying points you can get for those terms to get the 3 marks. There's 4 ways, the way I've written it, of getting the 3 marks. Here's the mark scheme, if you want to stop the video and take a look. Part A, showing you how they've done it, what they give marks for, and they're giving you a set of notes as well in the second column that you can read carefully. Just remember, mark schemes are written for examiners and teachers, so students need to make sure they understand what the mark scheme means. So if you, for example, have got the power of 10 wrong, POT stands for the power of 10, like you forgot to change the mega, into 10 to the 6, they will give you credit for the rest of it and just remove 1 mark for failure to change mega into 10 to the 6. So, part B is about the diagram, B1. So you can see what they've written, you can stop the video. Remember, when you're watching my videos, I would recommend watching them at 1.5 times the normal speed, because obviously when I'm recording, I need to talk slowly and clearly, but when you're listening, it will speed up the process for you if you listen at 1.5 speed. Okay, so the final way you can get the 5 marks, the 3 marks for the final bit, I think I put 4 of them down. Here's, they've got 5 of them written down, okay? So I'll let you stop the video and look through that. Question 5 shows a camel. The drawing shows a camel and a person in a desert. So camels are well adapted to the desert. They got big feet. Describe a method you could use to find the pressure a person exerts on the ground, standing on 2 feet. Yes? So remember, pressure, the theory, is pressure when you stand on your feet is force, which will be your weight, divided by the area of your 2 feet, because they're wanting you to talk about the pressure when you're standing on 2 feet. If you stand on 1 foot and you hold the other one up, the pressure on 1 foot will be double the pressure on 2 feet. And then you've got to, because it's a method, you've got to describe the equipment. Apparatus means scientific equipment. Yeah, so how will you measure the area of the feet? What tools will you use? Yeah, and how will you measure the mass? And how will you determine the weight? Remember, weight is mass times gravity. So you've got to write out your answer, including all of these points that I've made, into the correct depth, with the correct amount of detail, and in clear English. We'll have a look at the mark scheme straight away. So they're giving 5 ways that you can get the 4 marks. Yeah. So for example, when you want to work out the area of the feet, you can trace around the foot, someone's foot, on a piece of graph paper and see how many squares it occupies and estimate their feet that way. Now remember, when you are measuring mass, you're using a mass balance, and the best way of saying that is to use a balance. Yeah, sometimes they don't like the use of the word scale because it's too general. So use a mass balance is the best way of doing it. Yeah, but in this case, once you know, you can then calculate, measurement of weight or calculation of weight from the mass. Okay, and then obviously to use the equation. Once you've got the weight and you've determined the area, it will give you your 5 marks. The next bit, they want you to calculate the pressure, I think, on the camel feet. All right, so the camel have much bigger feet than humans, and it has 4 feet. So they're giving you information about the camel feet to 2 significant figures. They're saying the total area of contact of the camel's feet is 1,300 or 1,300 centimeters squared. Okay, they want the answer in newtons per centimeter squared. You should sometimes look here to see what units they are using. Okay, the normal units would be newtons per meter squared, but they're using centimeters squared, and that's quite valid. Now remember, the mass of the camel is given, again, to 2 significant figures. But remember, the mass is not what you put in the force, in the pressure equation. You've got to put force, and the force is the weight of the camel on its feet. So once you've got 6,600, you've got to multiply this, once you've got 660 kilograms, you've got to multiply by 10 in GCSE for the acceleration due to gravity. G is, remember, is 10, so it'll be 6,600. So 660 times 10 divided by 1,300, the area of the feet of the camel. And if you put the calculator value, it might come out to something like 5.08, rounded up to 3 significant figures. But again, you want it to 2 significant figures because the data provided is only given to 2 significant figures. Okay, so that's question 5. And here is the mark scheme for part B. Here, A and B you can see in one go. I'll let you pause the video. So I've done 2 more questions. I'm not going to do question 6 in this video because it's a 13-mark question, and this time it's about waves and about density, so we'll come back to it. I'll pause the video here. Remember to like, share the video. I do these for free. It's for anyone who wants to watch them. I know the November 23 one I did has already got well over 1,000 views, so do pass them on to friends in other schools. It is quite helpful for someone who wants to see how they can improve their exam technique, and make sure you have subscribed so you can get notified. Thanks for watching. Catch you in the next video. Bye.